Corrosion inhibitors in oil and gas pipelines.
Pipelines are used in the industry to transport oil and gas products from the well to central processing plants or downstream locations, sometimes over long distances.
During the transportation of oil and gas in pipelines, it's common that wells produce other products that are likely to cause corrosion, such as water and carbon dioxide.
Long-term damage to pipelines can lead to oil spills. Corrosion inhibitors are chemical compounds that are added to a fluid to reduce the rate of corrosion in materials in contact with the fluid.
Example, an inhibitor will be injected into the stream of hydrocarbon near the wellhead to reduce corrosion in the steel of the pipeline.
But how does corrosion inhibitors work?
They work by forming a protective film on the metal, preventing corrosive elements contacting the metal surfaces.
The main mechanisms for corrosion are caused by gas such as carbon dioxide, hydrogen sulfide, or oxygen, and corrosion influenced by microorganisms.
Factors affecting corrosion and corrosion inhibitors. Flow characteristics.
In multi-phase flow, corrosion occurs on the top of the pipeline, also called as top-of-the-line corrosion, TLC. Cannot be treated due to the lack of inhibitors on the top of pipe wall.
Temperature.
Carbon dioxide corrosion rate. In the presence of water, corrosion is increased as temperature of the flowing fluid or pipeline is increased until corrosion forms.
And also pre-corrosion.
Inhibitor performance are usually impaired after a long period of precaution scenario. This results in localized corrosion attacks.
But how do we determine the effectiveness of inhibitors?
We can use this inhibitor likelihood success score, ILSS, which is score-based 4 factors,
Which are
Operating temperature,
shear stress
total dissolved solids,
and predicted corrosion rate. A high score would mean that the specific chemical corrosion inhibition would be less effective unless high concentration is used. The table below shows the range of values of score and the effectiveness of the inhibitor. Wow! We have learned so much today. We now know that corrosion is a natural problem of material deterioration that will always exist, and corrosion must be reduced as much as possible by using inhibitors as to not bring great material loss or hinder production. Let's inhibit corrosion.